Good morning. Today we will be evaluating and calibrating this Wild T2. This is my newly acquired instrument. This is what I've been after for about 7 years now. And so this is this is called the T2 mod or new style. This particular mod here was manufactured in 1987. They came in this plastic case versus the older bullet case. And so I'm going to start off by evaluating and calibrating the tribrac, which I have already done, but I will walk you through the process on how I did it. We're going to be using several different instruments to do that. This has a dual electronic compensator with laser plummet, and this is just an older style Wild T2. And so what I've done here is I've set the legs up centered over a point, and I've got the tribrac mounted on the head here, and I've already gone and centered the circular vial via my legs, and so I'll walk you through the process on how I calibrated this bubble. So we'll start there. So now what I've done is I've mounted the Leica T110 onto the Wild T2 tribrac, and I used the dual electronic compensator, which you have your trunnion and your sighting, and you get it plumb, and you can see that your circular vial up top will coincide if you're calibrated. This was calibrated about a year ago, and so it's in pretty good shape still. And so now you want to release this from the tribrac and take a look at your bubble, and then you have a couple of there's some pins that you can use to adjust these two, and then there's one in the back that you have to use a 90 flathead in order to tighten up or loosen up that particular screw in order to move this bubble around and center it up. So I'm going to remove this and see where kind of shape my bubbles in. Well, it looks like it's in pretty good shape. I adjusted this tribrac yesterday, so I'm not going to mess with it anymore today. Now I'm going to mount the instrument up here, and we'll take a look at the plate level. After I calibrated that tribrac, I went ahead and removed this instrument from its tribrac and mounted it on that tribrac. And I paid attention to my plate level down here. I got parallel with these 2 foot screws, and the bubble centered up real nice. And then I went ahead and I advanced it 90 degrees, and I was a little out, so I took out half that error. I came back, took a look, I centered up, spun 180, and we were good. So that meant that I had a nice, between the legs and the upper portion of the tribrac were parallel with one another. And then I removed it, and then I put that instrument in its place, and I'll show you how I calibrated that plate level. I mounted the instrument onto the calibrated tribrac. That plate level was buried to the opposite side of the vertical circle, which would be this side over here. So what I needed to do was bring the plate level centered, and so I did that by using one of these pins to adjust that screw inside here. Now what you want to do is, depending on which way you have to turn, is, let's say you're turning counterclockwise, that would be away from the spring. In this case I had to turn clockwise, so against the spring. But let's say you have to turn anti-clockwise. You would want to bring your bubble, you'd want to turn anti-clockwise. You pay attention to the graduations here so that your bubble would overcompensate, so that because you want your final turn to be against the spring, about a quarter of a turn against the spring. So keep that in mind. Something to note, when you have the instrument in this orientation and you're parallel with these 2 foot screws, as you're adjusting this bubble, you're using both hands here. You've got your right thumb pushing in or clockwise. You've got your left thumb pushing in or anti-clockwise. The left direction of this side, this left foot screw, whatever direction your thumb is moving is which direction the bubble will go. Now, kind of what you want to look for is you want to look for very small movements out of the adjustment of these foot screws, but you want to see a lot of movement in the bubble, because that will let you know that your calibration is on, because you won't get any movement out of this bubble here. So then what you'll do is, once you have your bubble centered, is you will rotate 90 degrees like this, and then now your calibration, or now you'll be adjusting that through this foot screw here. And so you'll just kind of work your way around until you have that bubble in the center. Now, if that bubble does not go in the center, that's okay. Like right now, I won't bring that bubble completely to the center. I'll just take out what's called half the error. And as long as that bubble, let's say that bubble, is biting this graduation here, as long as it does that all the way around, you're plumb. So now what I want to do is I want to turn a few angles and see if I can't solve for either an angle or the opposite side of the triangle. And so I've got a mag nail that I set, and then what I did is I wheeled off a distance 10 times and then found the average of that distance to that target down there, and then I've grabbed the height of that target and the height of my instrument, and then so now we'll just use several zenith angles and then figure out what that average angle should be, and then we'll adjust our vernier to reflect that via this little screw here. You unscrew this, and then there'll be another little where you can adjust. Once that's done, then we will peg it. So we'll set the instrument at 90 using 2 staffs, and then we'll adjust our crosshair that way. Okay, so here are the 5 sets that I took. And I turned these as quickly as I could. I didn't worry about summing the angles. I just went ahead and got my face left and my face right, and then quickly turned to the next set. And then I went through and I did the computations. So I went ahead, I recorded my face left and my face right. I summed those two, and you can see that I'm short. I had a 359, 59, 25. I was short some 30 arc seconds. And then so what I did is I did that through each set, and then I minus this from 360, and the remainder from 360 I divided by 2, and because I was short, I added to my face left, and that gave this a corrected face left of 89, 16, 10.5 arc seconds. Now this instrument reads, the least count is to the nearest arc second, but you can call the ball, between the 2 hashes, between the 2 ticks. So what I did then is I added all these corrected face lefts and then divided by 5, the amount of sets that I had. And I came up with an average of 89, 16, 11.5. And so what I did was I pointed my crosshair at the target. It's not really picking up the crosshair, is it? There we go. This is an inverted image. And so I pointed my crosshair at the target, and then I turned the micrometer scalp here to read off that angle, which was the average angle. And then I turned this screw here to bring the scale into coincidence. And now I'll take it out and I'll tie into some control and grab some angles. So before we get this thing out and break the hearts of flat earthers, there's one final step. And so just to briefly go over the steps that we've gone through so far, we've calibrated the circular vial on the tri-brack. We've calibrated the plate level. We have the vernier reflecting the average mean turn between 5 sets. So now we just need to figure out, where's our crosshair at? Does it need adjustment? And so the way that I'm going to do that is I'm going to set a staff at this location down here, put the instrument halfway between 200 feet. So I'll have 100 feet in that direction at that staff, 100 feet over here. That'll be noted as position 1. That will be staff A, that will be staff B. We'll set the instrument at 90 and read off the rod readings in both A and B. And then once the instrument gets moved, that will be position 2, and then we'll read off A and B again, set at 90, do the math, and figure out what that nominal reading should be, and adjust our crosshair to reflect that on the rod.